The National Electrical Code, or NEC, addresses the installation and protection of transient voltage surge suppressors, or TVSS. When a TVSS is installed on the load side of the main breaker, the NEC does not mandate a separate disconnecting means specifically for the TVSS. This is because the main breaker itself is considered a suitable disconnecting means for both the TVSS and the electrical loads it is intended to protect. The rationale behind this allowance lies in the function of the main breaker. It serves as the primary overcurrent protective device for the entire electrical panel and everything connected downstream. In the event of a fault or the need for maintenance, the main breaker can be switched off, de-energizing all circuits connected to the panel, including the TVSS. Now let's consider a scenario where the TVSS is installed on the line side of the main breaker. In this configuration, the NEC typically requires a separate disconnecting means for the TVSS. This is because the main breaker does not provide overcurrent protection for the TVSS itself. If a fault occurs within the TVSS, it could potentially create a hazard without a dedicated disconnecting means. In this case, a fuse or circuit breaker would be necessary to protect the TVSS and allow it to be safely isolated for maintenance or replacement. However, since the question specifically addresses a TVSS installed on the load side, we will focus on that configuration. The NEC article related to surge protective devices is Article 242. This article covers the requirements for the installation, connection, and protection of surge protective devices intended for installation on premises wiring systems. Within Article 242, there are specific sections that address disconnecting means and overcurrent protection. However, these sections do not explicitly require a separate disconnect for a TVSS on the load side if the main breaker serves as the disconnecting means. Several factors influence the decision of whether to install a separate disconnecting means even when not explicitly required by the NEC. Firstly, convenience is a consideration. A separate disconnect allows for the TVSS to be isolated without de-energizing the entire panel. This can be useful for troubleshooting, maintenance, or replacement of the TVSS. Secondly, enhanced safety can be achieved with a separate disconnect. Although the main breaker can de-energize the entire panel, a dedicated disconnect for the TVSS allows for more precise control and isolation during maintenance or emergencies. Thirdly, local amendments to the NEC may exist. It is crucial to consult local electrical codes and regulations, as they may have stricter requirements than the national NEC. Local jurisdictions may have amendments that mandate a separate disconnect for TVSS installations regardless of their location relative to the main breaker. Now let's delve into the technical aspects of TVSS installations. A TVSS is designed to protect electrical equipment from transient voltage surges, which are short-duration high-voltage spikes that can damage or destroy sensitive electronic components. These surges can originate from various sources, including lightning strikes, utility switching, and internal electrical equipment. The TVSS works by diverting the surge current to ground, thereby limiting the voltage that reaches the protected equipment. When selecting a TVSS, several factors must be considered. Firstly, the voltage rating is a critical parameter. The TVSS must have a voltage rating that is compatible with the electrical system on which it is installed. Secondly, the surge current capacity is another important specification. This indicates the amount of surge current the TVSS can safely handle. Thirdly, the protection mode should be considered. TVSS devices can offer protection in various modes, such as line to neutral, line to ground, and neutral to ground. The selection of the appropriate protection modes depends on the specific application and the types of surges that are likely to be encountered. Now, let's discuss some common misconceptions regarding TVSS installations. Firstly, it is a misconception that a TVSS will protect against all electrical problems. A TVSS is specifically designed to protect against transient voltage surges. It will not protect against other electrical problems such as overloads, short circuits, or voltage sags. Secondly, it is a misconception that a single TVSS installed at the main panel will protect the entire facility. While a main panel TVSS provides a valuable layer of protection, it is often necessary to install additional TVSS devices at downstream panels or individual equipment to provide comprehensive surge protection. Thirdly, it is a misconception that all TVSS devices are created equal. The performance and reliability of TVSS devices can vary significantly depending on the manufacturer, design, and quality of components. It is essential to select a TVSS from a reputable manufacturer and to ensure that it meets the appropriate standards and certifications. When installing a TVSS, proper grounding is essential for effective surge protection. The grounding conductor must be properly sized and installed according to the NEC requirements. A programmed connection can significantly reduce the effectiveness of the TVSS and may even create a safety hazard. The NEC provides specific guidelines for grounding and bonding in Article 250. This article covers the requirements for grounding electrode systems, grounding conductors, and bonding of metal enclosures and equipment. Adhering to these requirements is crucial for ensuring a safe and effective electrical system. Let's consider some practical examples of TVSS installations on the load side of the main breaker. In a residential setting, a TVSS may be installed in the main electrical panel to protect sensitive electronic equipment such as computers, televisions, and appliances. In a commercial building, TVSS devices may be installed in panel boards that serve critical loads such as data processing equipment, medical equipment, or security systems. In an industrial facility, TVSS devices may be installed at motor control centers or individual machines to protect against voltage surges caused by motor starting or other industrial processes. In all of these cases, the main breaker serves as the disconnecting means for the TVSS, provided that it is installed on the load side. However, it is still advisable to consider the benefits of a separate disconnecting means for convenience and enhanced safety. The NEC also addresses the use of surge protective devices in specific applications such as fire alarm systems and critical operations power systems. In these applications, the NEC may have additional requirements for surge protection and disconnecting means. It is essential to consult the specific NEC articles that apply to these applications to ensure compliance. In summary, when a TVSS is installed on the load side of the main breaker, the NEC does not require a separate disconnecting means. The main breaker serves as the disconnecting means for both the TVSS and the loads it protects. However, a separate disconnecting means may be desirable for convenience, enhanced safety, and compliance with local codes or regulations. Proper grounding and bonding are essential for effective surge protection, and it is crucial to select a TVSS that is appropriate for this specific application and electrical system. The NEC Article 242 provides the guidelines for surge protection, and one must refer to local codes and regulations. Now, let's expand on the different types of TVSS devices available in the market. There are primarily three types of TVSS devices: Type 1, Type 2, and Type 3. Firstly, Type 1 TVSS devices are typically installed at the service entrance of a building. They are designed to withstand high surge currents and provide protection against external surges, such as those caused by lightning strikes or utility switching. Secondly, Type 2 TVSS devices are installed at distribution panels or subpanels. They provide protection against surges that originate within the building or that have been attenuated by the Type 1 TVSS device. Thirdly, Type 3 TVSS devices are installed at the point of use, such as at an individual outlet or piece of equipment. They provide the final layer of protection against surges that may have bypassed the Type 1 and Type 2 TVSS devices. The selection of the appropriate type of TVSS device depends on the specific application and the level of protection required. In general, a layered approach to surge protection is recommended, with Type 1 devices at the service entrance, Type 2 devices at distribution panels, and Type 3 devices at the point of use. This provides comprehensive protection against a wide range of surge events. Now, let's discuss the importance of regular inspection and maintenance of TVSS devices. Over time, TVSS devices can degrade due to repeated exposure to surge currents. This degradation can reduce their effectiveness and may eventually lead to failure. It is essential to inspect TVSS devices regularly to ensure that they are functioning properly. Some TVSS devices have indicator lights or audible alarms that alert users to a fault condition. Others may require periodic testing with specialized equipment. The frequency of inspection and maintenance depends on the specific TVSS device and the severity of the surge environment. In general, it is recommended to inspect TVSS devices at least annually and to replace them if they show signs of degradation or failure. Now, let's delve into the economic benefits of installing TVSS devices. While the initial cost of installing TVSS devices may seem significant, the long-term benefits can outweigh the costs. Surge protection can prevent damage to sensitive electronic equipment, which can save money on repairs or replacements. It can also reduce downtime caused by equipment failure, which can improve productivity and profitability. In addition, surge protection can extend the lifespan of electronic equipment, which can further reduce costs. In many cases, the cost of a single surge event can exceed the cost of installing a comprehensive surge protection system. Now, let's consider the environmental benefits of installing TVSS devices. By protecting electronic equipment from damage, surge protection can reduce the amount of electronic waste that is generated. Electronic waste contains hazardous materials that can pollute the environment if not properly disposed of. By extending the lifespan of electronic equipment, surge protection can also reduce the demand for new equipment, which can conserve resources and reduce energy consumption. In addition, surge protection can improve the energy efficiency of electronic equipment by preventing damage that can degrade performance. Now let's discuss some common mistakes to avoid when installing TVSS devices. Firstly, it is a mistake to install a TVSS device without properly grounding it. A poor ground connection can render the TVSS device ineffective and may even create a safety hazard. Secondly, it is a mistake to install a TVSS device that is not rated for the voltage and current of the electrical system. An undersized TVSS device may not be able to handle surge currents and may fail prematurely. Thirdly, it is a mistake to install a TVSS device in a location that is not easily accessible for inspection and maintenance. A TVSS device that is difficult to access may not be inspected regularly, which can lead to undetected degradation or failure. Fourthly, it is a mistake to assume that a single TVSS device will protect the entire facility. A layered approach to surge protection is recommended, with TVSS devices installed at the service entrance, distribution panels, and point of use. Fifthly, it is a mistake to neglect regular inspection and maintenance of TVSS devices. TVSS devices can degrade over time and may need to be replaced periodically. Now let's delve into the future trends in surge protection technology. Advances in materials science and electronics are leading to the development of more effective and reliable TVSS devices. New TVSS devices are being designed with improved surge current capacity, faster response times, and enhanced diagnostic capabilities. In addition, there is a growing trend towards the use of smart TVSS devices that can communicate with building management systems and provide real-time data on surge events and device performance. These smart TVSS devices can help to improve the overall reliability and efficiency of electrical systems. In conclusion, understanding the NEC requirements for TVSS disconnects is crucial for ensuring electrical safety and protecting valuable equipment. When a TVSS is installed on the load side of the main breaker, a separate disconnecting means is not required. However, it is essential to consider the benefits of a separate disconnect for convenience, enhanced safety, and compliance with local codes or regulations. Proper grounding, regular inspection, and maintenance are also essential for effective surge protection. By following these guidelines, we can protect electrical systems from the damaging effects of voltage surges and ensure the reliable operation of electronic equipment.